Hey guys, welcome again. When dealing with indices and power numbers, you must be able to simplify and evaluate properly. And past papers contain lots of questions to test your ability in those. For example, you might be asked to simplify a power number raised to another power. In this case, you must use the property related to this situation, which is that raising a power number, let's say a to the power n, to another power, let's say m, then the result is a power number of index n times m. Basically, you multiply the indices together. So when x to the power 3 is raised to the power 4, it can be rewritten as x to the power 3 times 4, which is x to the power 12. Similarly, as seen in another paper, when w to the power 5 is raised to the power 4, we can use the same property of power, so we can rewrite this as w to the power 5 times 4, which is w to the power 20. Of course, it is not always that easy. There can be some harder variations of this. Here, for example, you are asked to simplify x to the power 3 y to the power 4 times x to the power 5 y to the power 3. In this case, all terms are multiplied together even if some multiplication operators are not written. And we can use the commutative property to reorder the terms as x to the power 3 x to the power 5 times y to the power 4 y to the power 3. The first two power numbers have the same base, and therefore we can add their indices together as per the property of multiplying power numbers. So x to the power 3 times x to the power 5 can be rewritten as x to the power 3 plus 5 or x to the power 8. Same for y to the power 4 times y to the power 3. It becomes y to the power 4 plus 3 or y to the power 7. And our most simplified version now is x to the power 8 y to the power 7. Let's do another one. Here you need to simplify 27x to the power 6 all to the power 1/3. The index 1 over 3 can be distributed to 27 and x to the power 6 as per the multiplication rule. A times b all to the power n equals a to the power n times b to the power n. So we'll have 27 to the power 1/3 times x to the power 6 all to the power 1/3. We can simplify this one using power of power as shown earlier. Indices multiplied, so x to the power 6 times 1/3 or x squared. But this one here is a number raised to a number. So simplifying it is basically evaluating it as a single number. Here 27 is raised to the fraction 1 over 3, which is according to the root notation using indices is equivalent to the third root of 27, which is 3. And that is the simplest we can do. 3 times x squared. Let's do more examples about evaluations. This question here asks you to evaluate 8 to the power 2/3 times 49 to the power minus half. Let's evaluate each of these terms, then multiply them together. Starting with 8 to the power 2/3, the index here is not an integer or 1 over integer, but we can make it so. 2 over 3 can be rewritten as 1 over 3 times 2. And since multiplication of indices is equivalent to power of power, we can rewrite 8 to the power 1 over 3 times 2 as 8 to the power 1 over 3 all to the power 2. 8 to the power 1/3 is the third root of 8, which is 2. And 2 to the power 2 is 4. Done for the first term. Now we do the other term, 49 to the power minus half. The negative index can be turned positive by taking the reciprocal. So 49 to the power minus half can be written as 1 divided by 49 to the power positive half. And the rest is easy. 49 to the power half is the square root of 49, which is 7. So 49 to the power minus half is 1 over 7. Now what remains is simply multiplying the values we obtained. 4 times 1 over 7, which is 4 divided by 7. And that's our answer. One last example to go. Here you need to find the value of 64x to the power 4 all raised to the power 0.5 times 4x to the power minus 2. You might wonder at first how you're going to find the final value when there is an unknown x involved. And the answer should be that this unknown must cancel out somehow. And indeed, that is what's going to happen. First, we need to simplify the term 64x to the power 4 all raised to the power 0.5. The index 0.5 can be distributed to the multiplied terms inside the brackets, which gives 64 to the power 0.5 times x to the power 4 all raised to the power 0.5. 64 to the power 0.5 is basically the square root of 64, which is 8. And x to the power 4 all raised to the power 0.5 is x to the power 4 times 0.5, which is x to the power 2. Now we multiply this simplified term, 8x to the power 2, by the second term, 4x to the power minus 2. The constants multiply together to give 8 times 4, or 32. And x to the power 2 is multiplied by x to the power minus 2 to give x to the power 2 minus 2, or x to the power 0, which has the value of 1, because any number raised to power 0 is equal to 1. So our final answer is 32 times 1, or 32. And that's it for this video, guys. Good luck.